Yowzers, it's a pretty crazy time for space weather, so no screwing around. Here's a lot of solar imagery. So first of all, 94 angstroms, and yeah, X-class flare, as well as Proton Event, and some spectacular CMEs. We've got an inordinate number of videos today, so let's get down to it. You may find yourself needing to use the pause button today because we're not doing multiple runs of all of these videos. So familiarize yourself with the pause button. Yeah, so how you like them apples? Pretty sweet, right? Not too shabby. And let me cut that out before more tracks start playing. That's Golden Cat Productions, by the way. You can find links below the video and, of course, on the homepage to the original music. Alright, and before we get to coronal holes and so on, a brief look at sunspots. A very brief look. HMI continuum, there's magnetogram. Still got that massive sunspot 3576 pointing right at the Earth. These are the volcanoes that are erupting. Reykjanes has slowed down, and those are the rest on the list. Luatobe, Luatolo. Also Samaru, Merapi, Dacono, Popocatépetl, Fuego, Nevado de Ruiz, and Sabancaya. These are the quakes for the past 24, and one very interesting one indeed. Under the town of Pahala there, a 5.7 at the big island of Hawaii. Under Kilauea, of course, which is really part of Mauna Loa. But anyway, these are the quakes of a 5 and greater magnitude for the past 24. So it started out pretty slow, and then Fiji got a 5.3 at 540 kilometers estimated depth, and then New Zealand a 6.1. Largest quake of the past 24 hours was that 6.1 at New Zealand. Then Hawaii had a 5.7 at 20:06 this evening, universal time that is, and a swarm of other quakes in that same area, but none nearly as big as that. Also a 4.6 at Malibu. So a bunch of quakes down the west coast once again as the quake watch continues for the western North American continent. And Peru just had a 5.1. Let's get back to space as there is, there's a lot of stuff going on. So also a minor CME impact just showing up. So we'll see if that turns into anything more exciting. But at the moment, 10.7 centimeter radial flux is at 183 solar flux units. There it is in the 1 year chart. The black line is what we're talking about there. Space Weather Enthusiast dashboard here, not forecasting. Oh, it is forecasting a little bit of geomagnetic unrest right about now, and indeed there was a strike. So that is, it's not really describing what it's from. It's from a CME impact, by the way. Anyway, here's NOAA's Enlil spiral, and you can see 2 CME impacts there on the Enlil spiral. So Showing up on the 12th. NOAA there forecasting 2 CME impacts. The second one on the night of the 12th to the 13th. As far as NASA doesn't have any headed in Earth's direction. So, I don't know. Those are the forecasts. That's NASA's forecast, and that's NOAA's forecast. So, and of course, what's great about NASA's forecast is that it shows the interplanetary magnetic field line, that dashed line there. And of course, the current sheaths, that's the area in between north and south polarity, the sector boundary crossings of the heliosphere that we show later in the video. Anyway, these are the past 4 hours of Earth's magnetic moment from space. We don't have any geomagnetic unrest at the moment, but we may see some. So if the magnetic fields suddenly change, and they can, then you may see some geomagnetic unrest or even a mild geomagnetic storm. I thought this one was headed directly toward Earth, but it must only be a partial component of it. So that makes me suspect it was probably headed in both directions, both away and toward Earth, the opposite direction and toward Earth. That's a thing that can happen, by the way, especially in a crown prominence ejection, which is the one that this was. Anyway, here's the Earth's magnetic moment from the ground as well. So a little bit of an increase in the aurora here, but nothing major at the moment. So, but this could be extreme. I mean, there could be a huge bit of ejecta. Sometimes ejecta is headed right toward the imager, and it tends to not be, if it doesn't look like it's diffusing, you can have like a cylindrically shaped bit of ejecta. If it's coming right toward you, it doesn't really diffuse a lot necessarily. So anyway, KP index currently at 1. So definitely no geomagnetic storms at the moment, but you see this little impact here, a little bit hotter plasma showing up there. Like 4 times as hot, something like that. And yeah, we saw the solar wind density there get up to about 17. Maybe a little bit higher, just under 20 protons per cubic centimeter there for a moment. The magnetic fields never got real strong. Only 8 nanotesla there in that top pane, so not super strong fields. And a positive BZ, which is that red line, so not particularly good for geomagnetic storms, inducing current into Earth's system and so forth. So there's the Discover. Saw a very similar uptick there in both plasma temperature, velocity, and of course this does look a little bit like a coronal hole high-speed stream, interestingly enough, but they usually don't show up quite like that. So could be actually 2 intersecting coronal mass ejection impacts. So also a little impact showing up down here. So we're starting to see some plasma showing up, and of course significant proton event happening today, which we'll get to here in a moment. Check out the big dips going on in the magnetometers right now. Magnetometers dropping off a cliff there, both the GOES 16 and GOES 18. So right after midnight, right after noon local time, a huge dip in the magnetometer, especially the GOES 18, the blue line. So the N above that means noon local time for the magnetometer. So maybe some massive amounts of satellite drag happening there. It did have to maneuver itself around midnight local time for the GOES 16. So anyway, here is the top view ecliptic plane field plot. Earth just moved into a North Pole sector yesterday, and Earth remains there where it should for days. Here's our line of sight field plot, and yeah, a bunch of magnetic fields depicted there. Don't know what they mean? Ask us in the comments. There's our line of sight coronal hole plot. B field also depicted there, but coronal holes in red and green. And before we get to sunspots, there are coronal holes from... Let's try that again. There are coronal holes from SDO 211 angstroms. And not very impressive, so let's get to sunspots. So sunspots. That's a thing. And the sunspot number is now at, I don't know what it is. So, but here it is. Ta-da! Sunspot number at 137, 136, something like that. And here's our synoptic map by Spencer. And I'm over that. Of course, the most important sunspot at the moment is certainly 3576. It is still capable of producing X-class flares. Wait, let's actually go back to the synoptic map here for a minute. What's Spencer got to say about it? 10% chance of an X-class flare or a proton event. So 3576 is a sunspot to watch. It still is. And it looks like there may be another sunspot rising here over the southeast. Here's our flare probability monitor and scoreboard. And it's, yeah, again, very high risk of large solar flares, although that sunspot has degraded a little bit in the past day or two. So what's very interesting is some of the features of it. So wait till you see this. These absolutely berserk features here. The sunspot actually has a Boatman. Yeah, there's a Boatman on the sunspot right now. So you'll see. I'm not kidding. There it is. It's the Boatman of the River Styx. It's the Charon filament right there, folks. That represents not only magnetic shear, but that's actually an area that's more like the regular photosphere, just floating around in the middle of the sunspot. Absolutely bonkers. Yes, it's a plasma island in the sunspot with reverse polarity of the rest of the sunspot, I might add. So there's a great view of that. It's a Boatman, or perhaps an island. Pretty awesome, right? Check out the magnetic fields once again. So the leading fields there, those are south magnetic polarity, and the trailing fields are north magnetic polarity. And it looks a little bit like a paramecium. Anyway, there's the full disk equatorial view, and that's what about 135 sunspot looks like. All those groups fairly stable here for the past 24 hours. The amount of time depicted there. And by the way, we are running these videos at a slower speed today. They're 15 frames per second instead of the usual 30. So if something looks funky, that's what it is. And geez, oh whiz. Son of a beehive. That is... How you like them apples? That's pretty sweet. That is bonkers. Bonkers, I tell you. Yeah, so that sent a massive proton event. I think it's the second strongest. It might be the strongest proton event of the entire solar cycle so far. And we have significant polar radio blackouts, especially in the south polar region, from protons emitted sometime around the time of that flare. Protons traveling at a significant percentage of the speed of light. I haven't timed this one, but we did a Ask a Particle Physicist segment about it. I even calculated the speed of the particles. And there's a pretty sweet money shot for you. Let that one sink in. That is an X-class solar flare depicted in SDO 131 angstroms. .131 is the hottest wavelength on the SDO. And I have no idea what the temperature is. I don't memorize stuff like temperatures. But it is ionized iron. Extreme ultraviolet light emissions are what 131 angstroms is. A very, very specific spectra of the ultraviolet light spectrum. And there's the full disk equatorial view, or the equatorial view, I should say. And let's get to CMEs. You're probably worrying about that one being headed toward Earth, right? Well, it's not. But check out the Proton Event. I mean, that's a pretty berserk Proton Event. And of course, we sent warnings to smashomash.com/Smash Team members about that. Smash staff sent them, at least. So yeah, big proton event there, and it did involve all three energy levels, both the 10 and the 50 mega electron volt proton flux, but the 100 mega electron volt proton flux only had a little bit of a jump there. And if you look at the peak flux of this X-class flare, it was at 1320. Particles started to arrive already at 1420, so they only took 1 hour. So that's something like 1/3, 1/4 the speed of light. Pretty fast particles there. Another X-class flare to add to the list. And I think we actually have it on this. Yeah, so we actually have the spike here. So here's the arrival of those protons. Fantastic. Here you can see that polar radial blackout starting, especially at the south pole. And then levels are going to rise, and you're going to see that north polar radial blackout. That's the actual protons emitting radiation. And then you've got the equatorial brownouts caused by the actual flaring activity. So the sun's X-ray output is pretty beefy right now. I mean, the background flux, the average flux for the past 24 hours has got to be like nearly an M class, but the background flux is at about a C2? Yeah, about a C2, really. So some big activity happening there, mainly from an area around the far side. So a common occurrence, though, seeing large flares from sunspots that are no longer even visible. So here's your star chart. That's what's going on overhead, and I got to close this thing out, so let's got to move on here. Here's your solar system forecast. That's where things will be in 1 week. Here is your astronomy photo of the day. It's the Rosebud Nebula or something. Totally awesome. It's depicting, these red portions are sulfur, the blue is oxygen, and then the green is hydrogen, I believe. There is the orange. I don't know. I forget. Hydrogen, oxygen, and sulfur, though, are what are depicted there in the, what is it called? The Rosette Nebula. There you go. The astronomy photo of the day. And speaking of astronomy, let's talk about the differences between the different types of astronomy and cosmology and astrophysics and heliophysics, and what does it all mean, you may wonder? Well, what better move than to ask a particle physicist, right? So anyway, here's the Ask a Particle Physicist segment. And if you've never seen it before, well, congratulations on realizing the channel exists. Take it away, the monotone from Minsk. It's Eugene Bagashov.
Hello again. Would you help viewers to define and understand the differences and partial overlap between astrophysics, cosmology, astronomy, and heliophysics? Sure. What does astrophysics study? It studies celestial bodies. So this would be any physical entity, essentially, which is situated within the so-called observable universe, right? So this could be asteroids, these could be stars, these could be like, I don't know, plasma clouds, gaseous clouds, molecular clouds, galaxies, whatever, any of these, planets, obviously, things like that. So it's basically, you could say, kind of a mixed science in the sense that it has to use both physical methods, kind of like theoretical and experimental physics and things like that, and also chemistry, and also, well, that would probably be all, to be honest, mathematics, like theoretical mechanics, like things like that. Astronomy is very similar in this respect as astrophysics, because astronomy also studies the observable universe, But I guess the difference between astrophysics and astronomy is that astrophysics studies like typical phenomena and phenomena in objects, whereas astronomy, it focuses on like the ones that are actually observed. Like how would you say it? Well, let's say astrophysics studies the way, for example, I don't know, cities operate. But astronomy studies like some specific cities. Does that make sense? So astronomy like looks in the sky, says, okay, there's this galaxy, let's study it. Whereas astrophysics says, okay, well, let's consider a spherical galaxy in a vacuum, so to speak. Let's see how it works, if that makes sense. So there is definitely a partial overlap because we have to use astrophysical kind of laws or whatever, like, patterns, which we kind of observe in a vacuum, so to speak, no pun intended. We have to apply them to real objects that we observe in the sky, which is what astronomy studies, right? So yeah, that would be kind of the difference, but also an overlap, right? Now, heliophysics studies the sun, quite obviously, but not just the sun as an isolated object, but also various emanations of solar influence. For example, the solar wind, which exists basically in the up to 100 AU from the sun, 100 astronomical units. Phenomena like heliospheric current sheet, like the magnetic field within the solar wind, the things like that, like Forbush decrease, like the modulation of cosmic rays. Like potentially you might claim like all the space weather is also heavily related to heliophysics, if not a part of heliophysics in the first place, So there's a lot of stuff here, and it's not just the sun itself, right? It's also the solar influence in the system, right? And to a degree you might say, well, since the sun is a relatively typical star, like inductively we may make conclusions about other stars, even though technically if you study other stars, this is not heliophysics anymore, it's like one of the branches of astrophysics, I would guess. And finally, the cosmology, it studies the universe as a whole. So as I've said once, the galaxy is a dot for cosmology. Galaxy doesn't have any size in cosmological terms, so we're talking about like really big distances, really big objects, like galactic clusters, the way they move with respect to each other, like how the universe works in general. Of course, this is all heavily plagued in a bad way by the Big Bang hypothesis, which is completely wrong if you ask me, but that's a separate discussion. And properly, like if you name it properly, Big Bang is about cosmogony, which is like the beginning of the universe or the appearance of the universe, whereas cosmology proper should study like the structure and processes in the universe as it is, not as it began. But I mean, I can't say how Big Bang is bad. Like I can say enough, can't emphasize enough how bad it is. But again, it's a separate discussion. So cosmology studies the universe as a whole, right? And compared to cosmology, astrophysics studies something which almost doesn't exist in the sense that it is so small, right? And let alone things like heliophysics, right? For cosmology, the sun doesn't mean anything. But obviously, I mean, there are some connections between these sciences. Like, for example, Big Bang cosmology tells us we should have certain elemental abundances because of primordial nucleosynthesis. And heliophysics observes the elements on the sun and is saying, well, you know what? There's not enough lithium over here. And cosmology says, well, screw you, I don't care. Like, if your observations don't match my theory prevails, things like that. That was obviously a joke, but you get the idea. I mean, there is a definite like exchange of info between all of these. Yeah, as usual in science. Hopefully this answers the question.
Alrighty, so thanks, Eugene, for that. And by the way, if you want to contribute, you can do so, and we'll tell you how in a minute. But first, make sure you're subscribed to Eugene's channel. Yeah, you got a question for Eugene? We'll tell you how to ask. But first, go subscribe. Eugene the Philosopher. You'll subscribe. Or solar protons will end up in your cereal bowl and they'll taste bitterly. They'll sour your milk. Solar protons. They'll rain down on the roof of your mouth and they'll taste like doggy doo. If you don't subscribe to Eugene the Philosopher. If you want to contribute, smashomash.com/forum is where to do so. And yeah, you can go to the Ask a Particle Physicist segment right there in the General Science Forum, and you'll find it. Just log in and post your question. We'll consider it. And let's get to coronal mass ejections. There were some major ones today. Are they earthly directed? Well, I don't think so. It's mainly that one associated with the X-flare, and it looks like it was too far away, but there could be a portion that is headed toward Earth. So let's take a closer look. All right, so we are seeing a partial halo there. Now keep in mind, oftentimes when a large flare happens, we have reverberations that ripple across the entire surface of the sun. So there can be multiple events going off that are triggered by, or that are sort of all associated with each other because the way plasma ripples around on the surface of the sun. So, but it does look like there is a partial halo there. I'm not so sure. I don't think that is earthly directed. It's from too far behind the sun. You can have a massive proton event like we see. Look at all the snow on the camera there. That is relativistic particles striking the SOHO spacecraft. Anyway, let's get the filaments. Oh, we got to show our custom coronagraphs, I guess. That would be kind of important, right? So there are our custom coronagraphs. And I could have sworn I saw some limb darkening when that CME launched. So you'll be able to see it here if it is a thing. But keep in mind, it looked like there was a CME happening in here around the same time. So there were radio bursts, and things can be a little bit deceptive there. It looks like there's a bunch of missing data on the coronagraph also. So you can have a major CME incoming and not even realize it sometimes, depending on how it's directed and how the data is available. So if you look down here, you may see some limb darkening. Oh geez, yeah, that is very what's the right word? Inconclusive, in my opinion. So, but if earthly directed ejecta is on the way, expect it to arrive sometime on the 12th. Here's a little closer view. So you definitely see some action in here associated with Sunspot 3576 as well. Yeah, so multiple events going on there. You can see plasma shifting all around here on the far side. So lots of stuff going on. Frankly, more than I'm able to comprehend at this time. So, but there you go. There, you be the judge. Let us know in the comments what you think. I don't think that one's going to be earthly directed. So we'll see what happens, and fingers crossed for an impact tonight. So check out this filament, these filaments right down here. And yeah, one definitely ejected. So I think that one is earthly directed. So, but that's not the same thing as the one that was associated with the X-flare. So yeah, that's a pretty minor filament. But hey, we don't have the data to see how it's really oriented yet. Let's take a brief look at stereo A. All right, so here's stereo A. Let's break out the difference imagery first. Wow, it got slammed with relativistic particles. Check that out. Stereo A was kaplastered. All right, let's check it out. You see, it looks like there's two events going on at the same time there. So the one from down here is earthly directed. The one from the X-flare on the far side, not earthly directed. Another CME headed this way, expected to arrive on the 12th. So before we get to bonus features, here we go with the ever-popular Go 16 SUVI. Past couple of hours there, lots of prominences, lots of stuff going on. Here comes bonus features. Charging hazards, we ain't got none. Space weather's chill. Goes electron flux, kind of a low range. As minor impacts begin. There is the electron flux at very low levels. There's Noah's forecast. I don't care. Here's the ionosphere. Yeah, that's what's going on above at about 300 kilometers of altitude. There's the anomalogram, anomaly in megahertz from a 30-day median, and we are indeed seeing some low-frequency anomalies there as the ionosphere is puffing up. Yeah, puffing up from space weather impacts. Plasma temperature does affect things, so temperature, magnetic field strength, magnetic field orientation, plasma speed, and density are all features of how it affects the F-layer. And here's the whole atmosphere model. The latest SDO images. And we'll briefly look at Sunspot 3576. Very nice. It's still Beta Gamma Delta class, and it's still capable of producing X-class solar flares. By the way, are you familiar with Hanlon's razor? Basically, I say this all the time on social media, folks. I say, never attribute a conspiracy that which is more easily attributed to basic stupidity and ignorance. Hanlon's razor is a similar concept. And basically what it means is, rather than assume somebody is doing something because of ill will or malice, assume that it's more adequately explained by stupidity, if so. So, never attribute to malice that which is attributed which is adequately explained by stupidity. In other words, if you go, why did he do that? Just assume that it's because of stupidity, not malice, because chances are it is. Anyway, we've also got our meteorology segment coming, so let's get to that. First, some stormy seas in the Atlantic. That's what's going on. That is significant waves, and those are 32-footers out there, probably not big enough to take out Marky Mark and George Clooney should they get on a boat all hunkily together. Two hunks on a boat probably won't be drowned by those 32-foot waves. So anyway, these are the surface winds of the east, jet streams. Jet streams of the central world. And the surface winds. Surface winds of the west. And the jet streams. Clouds and fog are next. For the Americas. And let's take a look at this Atlantic low that we showed you in the intro. Not too bad, in the middle of nowhere, and unlikely to be producing the perfect wave. Yes, I'm referring to a film called The Perfect Wave, which, you know, it's a very sad film because there's nothing sadder than watching two hunks drown at the same time. I mean, who wants that? Next, snow depth. Yeah, there's where the snow is. And we actually have some snow in Pennsylvania yet, but not for long. It's going to be like 60 degrees tomorrow, folks. Yeah. Anyway, here's our weather.gov map, weather.gov, to get your weather warnings. Don't expect me to give them to you because that's a lot of counties. Here comes some forecasts, courtesy of tropicaltidbits.com. As another Pacific atmospheric river makes its way across the U.S., a lot of moisture is coming especially to the southeast. That's GFS total accumulated precipitation forecast in inches. Here is our snow depth change in inches, and Texas is going to get some pretty heavy snow there in the stovepipe. Next, the jet stream forecast, and the jet stream is still staying very, very far to the south. Last but not least, the temperature anomaly forecast in degrees Celsius. Very warm temperatures there coming to the Gulf Coast as well. Also, northeastern Canada, super warm. West of the Rockies, a little bit anomalously cold. Next, lightning. And I'm over it, but we did have some strikes in Tennessee. We may have some terrestrial strikes going on when we make the video. So yeah, a little bit of lightning in Tennessee there, just east of Nashville. Yeah, Nashville. Do you like to drink soda pop in Texas on a Friday? Do you like to drink soda pop in Texas on a Friday, Smash Staff? She says no. She's a liar. She likes to drink RC Cola, her favorite soda pop in Texas on a Friday. Anyway, we'll close out with Doppler radar for the lower 48. Clouds and fog. And the water vapor map. That's what's going on. There's your recap. And here is me signing off and reminding you that to press the like button, visit our links, and until next time, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.